Greetings for the day. I am Shweta Rajoria, Assistant Professor at SIT Bhopal in EC Department. This is the third lecture of the MOOC course of Module 1 on wireless networks. In the last lecture, I have explained about GSM. What is GSM? What are its applications? What are the services of GSM? What is its architecture? What is the importance of GSM in 2G systems? What services actually GSM provides? And what are the features of the GSM? We have seen that SIM is the foremost important feature of the GSM. In the today's lecture, we will jump to CDMA. CDMA basically stands for the code division multiple access techniques. Before moving in depth towards the CDMA, first we will look what is actually the multiple access techniques. Multiple access techniques are those techniques where the multiple users can access the same channel simultaneously. These are broadly divided into the four subsections. One is the TDMA, another is FDMA, SDMA, and CDMA. TDMA stands for time division multiple access. FDMA stands for frequency division multiple access. SDMA stands for space division multiple access, and CDMA stands for code division multiple access. Now we will see the brief look on each the multiple access techniques. From the plots, you can see that in the FDMA, multiple users can send their signals simultaneously but at the different frequency band. For example, orange frequency band belongs to the one user, violet for another, and orange for another. From this figure, we can see that three users can send their signals simultaneously at different frequency band. This is your frequency division multiple access. Then the time division multiple access. In the time division multiple access technique, multiple users can access the same channel but at the different time. GSM is the example of the TDMA. In the GSM, we can see that we have the 200 kilohertz channel, and this 200 kilohertz channel is divided into the 8 time slot, and each time slot belongs to each user. This means 8 users are accessing the same channel and transmitting their signal. Then we comes to the code division multiple access. In the code division multiple access technique, multiple users can transmit their signal simultaneously through the common channel, but all the users have the different code word. That I have explained here, multiple signals in the same frequency band and at the same time. Each user have different codes, and we must take care of one thing. All the codes are orthogonal to each other. Now how the CDMA performs. Now we explain that in the code division multiple access, narrow band message signal, that is basically our voice signal, is multiplied by the signal which have very large bandwidth, and this signal is known as the spreading signal. This spreading signal is the pseudo noise code signal, that is PN code sequence. Basically, the PN sequence is the binary sequence and it is random in nature, but it can be generated by some deterministic manner, and the rate, that is known as the chip rate, of the pseudo node sequence is very high, and all these codes are orthogonal to each other. Before moving to the in-depth working of the CDMA systems, first we will see what are the advantage of CDMA system, what are the disadvantage of the CDMA systems. First, we will look on the advantages of the CDMA systems. One basic and the main advantage is multiple users can use the same bandwidth and transmit their signal simultaneously with the application of the CDMA. Another importance is that unlike TDMA and FDMA, CDMA has the soft capacity limit. That means there is no upper limit that these number of users can be accommodated in this amount of the bandwidth. Like in unlike in TDMA, we have seen that 200 kilohertz channel is used by 8 users only. There is the upper limit of 8 users can access the 200 limit channel. Different from that, CDMA do not have this thing. Any number of users can accommodate in the same frequency band and send their signals simultaneously. And each user have the different code word. At the receiver side, we receive the signal and demodulate it according to their code word. Then another important advantage is, as I have said, that CDMA is using the very large bandwidth, hence it has the very high data rate, that is very high spectrum efficiency. Next example is it is resistant to the interference. There is no concept of the interference, as we do not require any guard band that we have seen in the GSM systems. Next important advantage is it is resistant to the multipath fading, that is time domain interpretation, separate all time shifted path. Another is the frequency domain interpretation, that is signal is too wide to vanish. That is the coherent bandwidth of our signal is very high than the coherent bandwidth of the channel. Next are the CDMA disadvantages. There are mainly the two disadvantages while considering the CDMA system. One is the self-jamming, another is the near-far problem. In the self-jamming arises as the large number of users are accommodating in the same frequency band. When the user increases very large, the code allocated to each user are not exactly orthogonal, and we get the problem at the receiver side. This jamming is not due to the external interference. This is mainly because of their internal codes. Therefore, it is known as the self-jamming. Another important problem is the near-far problem. In the near-far problem in the CDMA, the main concept is that the signal having the high signal strength is received at the receiver side, while the signal with the poor strength is not received and it is considered at the interference. Self-jamming problem is self-removable. It can be removed by considering limited number of users in that band. But there are a lot of schemes that the researchers have developed for overcome or to overcome the near far problem, like CSMA CD, CSMA CS, that we will cover in our next lectures. Now we will see the working of the CDMA. Before moving to this, I want to tell you one thing. CDMA is the spread spectrum technique that I have mentioned previously also. Now, what is the spread spectrum technique? In the spread spectrum technique, basically, the transmission bandwidth of the signal is very large than the bandwidth of your message signal. Spread spectrum techniques are broadly categorized in the two parts. One is the frequency hopping, another is the direct sequence spread spectrum. CDMA belongs to the category of the direct sequence spread spectrum. Sometimes direct sequence spread spectrum is known as the CDMA. This is a working block diagram or the transmission diagram of the CDMA. What actually we do, we multiply our message signal, that is our baseband signal, to the PN code. PN code is generally a very large code, that is random code, pseudo noise code. After multiplying it with the pseudo code, here we get the spreaded signal. Then this spreaded signal is modulated by any technique. You can use binary PSK, you can use QPSK, you can use DPSK, another technique, any technique. After the modulation, we will get our required signal that we can transmit. For explaining, for understanding in the better way, I have taken one example. From this example, we can see that these are the user bit, that is our baseband signal 101. And this is your PN sequence, that is the signal having the very large bandwidth. We can see that this is the 7-bit code. So spread factor of this code will be 7. Now we need to multiply or XOR our this signal with this code signal. After multiplying 1 with this 7-bit, we will get this. That is 1 multiplied by 1, we will get 1. 1 multiplied by 1, again we get 1. 1 multiplied by 1, again we get 1. 1 multiplied by 0, we will get -1. In the similar manner, we have written all for all the 3 bits. Now from this, that we will get this end. Okay, in our transmission block diagram, the modulated signal will be obtained at this end, spreaded signal actually. Now from this we can see that our 1 bit is transformed into the 7-bit. That is, our signal gets spreaded. After spreading the signal, as we have seen here, our signal will be modulated by any of the modulated scheme that we adopted. And this is your frequency generator for corresponding to your modulation scheme. And after modulation, we transmit our signal. This is the complete transmission block diagram of CDMA. Completing the transmission block diagram, we will move to the receiver side. In the receiver block diagram, first we will multiply our signal by IF and wind filter. The importance of this filter is that by transmitting by moving our signal through IF wideband filter, we will remove the noise, and this will help to get the better quality of our signal. After that, this signal will come to our receiver block diagram. In this, first we will multiply our incoming signal to the PN code generator. This have the same set of sequences that we used in the transmission side, that is PN generation. And this must be kept in the synchronization for obtaining the correct signal or error-free signal. Now, after multiplying this, our incoming signal with the PN code generator, our received signal will get despread. Okay, that we will get our original signal, that what we have transmitted, but it is modulated. So we will passes our signal through this block diagram. This is the demodulator diagram of the scheme, whichever scheme we have adopted. After demodulated, at the transmitter, at the receiver side, you will get your received data. The important thing is that the PN generator system must be synchronized with your transmitter so that you will despread it properly. Now, what are our basic steps while considering the CDMA or DSS modulated transmitter and receiver? First, we will take our message signal, multiplied by the spreading signal, which is generated by PN decoder. After multiplying it with PN coded signal, you will get your spreaded signal. This spreaded signal is modulated according to the modulation scheme what we have adopted, and then it is transmitted. At the receiver side, this signal is despreaded. At the receiver side, this signal is first multiplied or passes through a IF wideband filter so that we can remove the noise. After that, this is again multiplied by our PN code generator, and this generator must be synchronized with the transmitted generator. Then we will get our de-spreaded signal at this point. After getting the de-spreaded signal, we will demodulate it according to the scheme that we have adopted. Thank you.